السلام عليكم ورحمة الله وبركاته. الحمد لله الذي علم آدم الأسماء كلها، علم الإنسان ما لم يعلم، الذي أعطى كل شيء خلقه ثم هدى، والصلاة والسلام على معلم الناس الخير سيدنا محمد وعلى آله وصحبه أجمعين. اللهم علمنا ما ينفعنا وانفعنا بما علمتنا وزدنا علما. بسم الله الرحمن الرحيم. Welcome to EE366 lab. In this lab, we will study how to program a microcontroller, how to program a PIC microcontroller. As you may have already seen in the class, a microcontroller has a central processing unit. It has a microprocessor along with different modules such as oscillator, analog to digital converter, memory, RAM and program memory, and different input and output ports. So in this lab, we are going to study how to interface all these different modules with the inside the microcontroller and program their functions. The goals of this lab is to be able to understand the working of all the components and modules of any microcontroller simply by using its data sheet. So by the end of the semester, you should be able to independently program microcontroller for any real life application by using assembly or C language. That means you will be able to program the microcontroller using its own instructions, special function registers, and you will be able to use the components and modules of a microcontroller without the help of any third-party functions, without the help of any built-in or third-party compiler functions. Now, when you look at a microcontroller or when you look at any machine, there are two approaches for the machine. One is the design approach and another is the application approach. For example, when you use a calculator, you simply press the buttons on the calculator to perform any calculation, and you don't have to know how the calculator actually performs those operations internally inside its own processor. So you are not concerned with how the numbers are stored in the memory, how they are calculated, how they are processed, and how the result is displayed on the screen. But on the design approach, you will study how the microcontroller or how the machine actually works. So you'll see how the data is entered, how it is stored in the memory, how is it processed by the ALU and the CPU, and how is it displayed on the output. So this is the design approach. So in this lab, we'll take the design approach of the microcontroller. We'll be learning how to design systems using the internal components of a microcontroller. The marks distribution for this lab is based on lab quizzes and lab tests. So you'll have after each lab, in the next week, there will be a quiz conducted on Blackboard, a short quiz conducted on Blackboard based on the lab that you have studied in the previous week. So for example, when you complete lab 1, in the next week, you will have a quiz on Blackboard based on the concepts that you have studied in lab 1. And similarly, you have 2 lab tests. The first test will be programming in assembly and the second test will be programming in C. The total marks for the lab is 20 marks. These are the different microcontrollers that we see in the lab. PIC 16F690 is a 20-pin microcontroller. PIC 16F917 is a 40-pin microcontroller. Then we have PIC 4550 and PIC 4580 microcontrollers, 40-pin microcontrollers. And we also have PIC 32 MX534 microcontroller. As you may already know, electronic circuits, they come in different IC packages. So you might have already seen a MOSFET which looks like this, or a transistor which has 3 pins. So this is one of the IC package. So this is another transistor package, and you may have seen a 555 timer, you may have seen op-amp, something like this or like this. So these are the different examples of different integrated circuits. So in the lab, normally we use the dual inline package of electronic circuits. So in the dual inline package, the IC looks like this. It can be easily placed on a breadboard for experimental purpose, and the pin numbering for the IC, it starts from this side. So when you look at the IC, you'll find there will be a semicircular notch here, and on this side there is a dot which indicates pin number 1. So once again, for this IC, there is a notch here, and pin number 1 is on this side. So numbering starts from here, it starts increasing until here, and then you go to the other side, and then it starts increasing until the end. So in this example, you have pin number 1 here, and it starts increasing until number 8, and then you have pin number 9 to 16. So this is the most commonly used dual inline package, which is used for experimental purpose and for the lab purpose. So we can easily build our circuit on the breadboard. We can test the circuit, and once we are sure that the circuit is working fine, everything is working fine, then we can go for the production package. So normally, when we design our own PCB, our own system, we do not use the dual inline package. Instead of that, we use one of these packages, either the quad flat package, or the QFN package, or the ball grid array, or the shrink small outline package. So once these are also different packages of the same IC, you can get microcontrollers. You can get microcontrollers in the dual inline package, and the same microcontroller will also be available in the QFP package or the QFN package. So in the quad flat package, once again, we will find a notch, we'll find a dot on pin number 1, and the pins, the numbering will start increasing, and it goes in the anti-clockwise direction. So as you see the example here, there is a dot which indicates this is pin number 1, and the pins starts increasing from here. You can see the dot here. So this is a ball grid array. If you look at the processor of any CPU, any computer, any desktop computer, if you look at the processor of any desktop computer, you will find it looks like this. It has several hundreds of pins just below the IC. So there will be an processor socket in the computer. In the desktop computer, you'll find there is a socket for the processor, and the processor itself is an IC which has hundreds of pins just below that, just beneath the IC, and you place the IC on the socket, and you latch the lock, or you close the lock for the processor, and then you connect the CPU fan on top of that. Normally, ICs, they use two different technologies for manufacturing. One is the TTL logic, which is transistor logic, and the other is the CMOS logic, complementary metal oxide semiconductor. Now, the most important connection that you must have for any IC is the power and ground. Without power and without connecting the power and ground, you cannot make any IC run, or you cannot switch on any IC. So for the TTL logic ICs, the power is connected on VCC pin and ground is connected on this ground pin. But for the CMOS ICs, you do not have a VCC pin. Instead of that, you have a VSS pin. So what is the meaning of this VSS? And you have a VDD pin. So in the TTL ICs, they are based on BJT. BJT is a transistor. So the transistor, it has collector, base, and emitter. So VCC stands for collector voltage. Collector is normally connected to the high volt, the positive volt, and the emitter is normally connected to the ground. So VCC is the collector voltage. VCC is the collector voltage, and it is normally connected to 5 volts, and ground is the VEE. But in CMOS ICs, instead of VCC, you have VSS. Now, CMOS is based on MOSFETs, and in MOSFET has a drain, gate, and source. So in a MOSFET, drain is always connected to the power, and source is connected to ground. So VSS stands for source voltage, which is ground, and VDD stands for drain voltage, which is power. Now, do not be confused between VCC and VSS. They sound similar, but they are entirely opposite. VCC is power supply, and VSS is ground, and VDD is the power here. So the microcontrollers that you will use in the lab, they all use CMOS technology. So and you'll find VDD and VSS as the two different pins for the power supply. VDD will be used for 5 volt and VSS will be connected to the ground. These are the different microcontroller boards that that are available in the lab. PIC2 starter kit. It has PIC 16F690 microcontroller, a push button, few LEDs, and a potentiometer. And this is the mechatronics demo board. Once again, it has a microcontroller connected here. It has an LCD, a DC motor, a stepper motor, UART connection. It has a light sensor and a temperature sensor, 2 potentiometers here, and a few buttons. And once we'll be using this mechatronic demo board to study how to interface all these different components to the microcontroller. And we also have a Duolingo board. The microcontroller is connected just below this LCD screen. So once again, you have a few push buttons, you have a few LEDs connected here, and on this expansion board you can connect different components as you like. All the pins of the microcontroller are available here on this header. So these are the different boards that we'll be using during our lab. Now, looking at the components of a microcontroller, you have 4 main components for the microcontroller: central processing unit, the memory, system clock, and the peripherals. So in the CPU, you have the ALU, arithmetic and logic unit, which performs all the arithmetic and logical operations on the data. So data must be first stored in the working register. So working register stores the data on which the current operation is taking place, and you also have an instruction decoder, which explains what the ALU has to do on the data, or the process that must be carried out on the data. Then you have memory. You have 2 types of memory here: the RAM, which is data memory, and ROM, which is program memory, read-only memory. So the program that you will be writing for the microcontroller to execute will be stored in the ROM, and user data, or the data on which any process is going to take place, that will be stored in the RAM. And it also has special function registers, and it has general purpose registers. So each special function register is used to configure a particular module inside the microcontroller. And the general purpose registers, GPR, they are used to store user defined data. The special function registers, the bits of the special function registers, they can be used to control different modules of a microcontroller. The next important feature, the next important component of a microcontroller is the oscillator. Oscillator generates the system clock. It is the heart of the microcontroller. It generates pulses at a fixed frequency. To execute any instruction inside the microcontroller, it needs a clock signal. And that clock signal is generated by the oscillator. So in PIC microcontrollers, you can connect external oscillator on the 2 pins of microcontroller, or you can use an internal oscillator inside the PIC microcontroller itself. So each oscillator frequency, the oscillator frequency inside the microcontroller is divided by 4. That means each instruction, it needs at least 4 clock cycles to execute. We will see that later on in details. So this is the block diagram of PIC 18F4580 microcontroller. It shows you all the different components that are available inside the microcontroller, and these are the external input output pins of the microcontroller. And the pins of the microcontroller, they are grouped in different ports. So you have port A, it has these pins. Then you have port B, port C, D, E, F, G, depending on the number of pins available for a microcontroller. Now, whenever we use a new electronic device or any new circuit, any new IC, we have to look at its data sheet to understand how that IC works. Now, what is a data sheet, and where to find a data sheet, how to use a data sheet? Data sheet is simply a technical document which explains all the details of an IC. Now, where to find the data sheet? Normally, the data sheet is provided by the manufacturer itself. So if you look at the website of the manufacturer, you can find the data sheet for the IC. So for example, the data sheet of PIC microcontroller is available on the microchip website, microchip.com. So if you search on the internet for PIC 18F4580, you'll open this page and you can find the link here, view data sheet. So when you click on this link, or you can click on the documents, and you can scroll down and find the data sheet here. You can also find the errata to look at any printing mistakes in the data sheet or in the timer module. There are some supporting documents, programming specifications, application notes. Okay. So all these documents will help you in programming the PIC microcontroller. Now let us look at this data sheet. So this is the data sheet for PIC 18F4580, and the same data sheet is applicable for PIC
2480, 2580, and 4480 microcontrollers. So the first page or the cover page of the data sheet, it shows you the big model numbers for which this data sheet is applicable. It also shows you the number of pins for this microcontroller and the technology used for this microcontroller, and a brief summary of what we can find in this data sheet. If we scroll down, we'll find on the second or third page a summary of all the modules and peripherals inside this microcontroller, or inside all these 4 microcontrollers. What are the special features of this microcontroller, the oscillator structure, the power management modes, and the peripherals. And there is a table given here which shows you the difference between these 4 microcontrollers for which this data sheet is applicable. So for example, the program memory, PIC 18F2480, it has only 16 kilobyte of program memory, whereas 2580 has 32 kilobyte of program memory. Similarly, the input and output pins for this microcontroller is only 25. For these 2 microcontrollers, 2480 and 2580, you have only 25 pins, and for 4480 and for 4580, you have 36 pins available for input and output. Similarly, you have 8 analog inputs, and here you have 11 analog inputs. So this table just shows you a summary of different modules and the memory inside this microcontroller, these microcontrollers. And if you keep scrolling down, you'll find the pin diagrams for these microcontrollers. Now we have seen before in the previous slides, what does SPDIP stand for, or SOIC stands for? So this is the shrink outline integrated circuit. So this is the shrink package. It is the small package of this IC. So it's only 28 pin IC now. And this pin diagram is applicable for PIC 18F2480 and PIC 18F2580 microcontrollers only. And the same 2 microcontrollers, they can also be found in 28 pin QFN package, which is quad flat package, the square type with no pins connected here. So the QFN package is a surface mount package. So when you build a PCB, the QFN and the QF package. So the quad flat package, QFP, QFN, and shrink outline, and the ball pivot array, these are all surface mount packages. That means when you build a PCB, the microcontroller or the IC is placed on the top side of the PCB, and the pins are soldered on the same side itself. But for the dual inline packages, if you build a PCB using dual inline packages, then these pins, they go through the PCB on the other side. So there will be holes for each of these pins, and the pins are soldered on the other side of the PCB. Now we find the pin diagrams for these microcontrollers, and here you have the dual inline package. Now 40 pin dual inline package, this is the one that we'll be using mostly in the lab and on the breadboard. So 4480 and 4580 microcontrollers, they have this dual inline package of 40 pin IC, and they also have the same microcontrollers. They also have QFP package, the QFN package. Okay, so whenever we look at the data sheet or the pin diagram, we have to make sure that we are looking at the correct pin diagram before we make our connections. Before we make our hardware connections, we have to look at the correct pin diagram according to the IC package that we are using. So this is what we find in the data sheet. Now if you keep scrolling down, you'll also find the table of contents, and you can easily jump to different modules from the table of contents. So you can find here, for example, the interrupts, input output ports, the timers, 10-bit analog to digital converter, and the instruction set summary. So these are the contents of the data sheet. And in the next few modules, or you can also use the bookmarks here. You can click on the bookmarks and you can easily jump to different modules or different sections of the data sheet using the bookmarks here. So for example, if you go to the oscillator configurations, you can find here the details regarding which oscillators can be used to connect this microcontroller or to run this microcontroller or to generate the clock signal for this microcontroller. So there are 10 different options available and you can choose whichever oscillator you want to use for running your microcontroller. Similarly, if you go to the timer module, for example, you can find all the details here related to the timer module. And these are the registers, the special function registers inside the microcontroller, which are used to configure this module. So for example, if you want to configure timer 0 module, then we use the T0 control register, timer 0 control register. So it has 8 bits, and each of these bits, they are used to configure certain feature of this timer module. So for example, bit number 6 is used to either enable the timer in 8-bit mode or 16-bit mode. So if it is 1, then you have 8-bit timer. If it is 0, then it can run as a 16-bit timer. So similarly, each of these bits will be used to configure a certain feature of this timer. So all this information you can find in the data sheet. These are the name of the bits. This is name of the register itself. These are the name of the bits. You have 8 bits, and here on top of each bit you find whether this bit is a readable bit or a writable bit, and what is the default value of this bit when you switch on the microcontroller for the first time. When you power on microcontroller, what is the value of this bit? Is it 0 or is it 1? That is given here. So all these bits are 1 by default, and all these bits, they are readable bits and writable bits. Now let's look at another example. So this is a UART module, serial communication module. Now in this register, DXSTA register, you find most of these bits, they are 0 by default. So when you switch on the microcontroller, you'll find that these bits are 0 by default, and these are readable bits and writable bits, but this bit is a read-only bit. So you cannot change the data in this bit. So you can only read the data from this bit because it is a status bit. So status bits, they indicate the status of this module in the microcontroller. So this is a read-only bit, and the default value of this bit is 1. So all this information you can find in the data sheet, and you can easily jump to different modules by using the bookmarks here. And if you scroll down, you'll also find the instruction set summary. So the assembly instructions that you are going to use to write your program, all those instructions are explained here in the data sheet. So this is the list of all the assembly instructions. So add WF, this is the mnemonic or the syntax of how you write the instruction, and you have the description here. What is the function of this instruction? You can find it in the description. How many instruction cycles it takes to execute this instruction, it is given here. And what is the machine code for this instruction? So for example, the first instruction, the machine code for this first instruction is 0010 00. D is the destination, whether it can be after executing this instruction. Where do you want to store the result? The W register or a file register. So depending on that, it will be either 0 or 1. Then you have A, which is for the access bank. So which access bank are we going to use from the data memory? And this is the file register location. And this column shows you which status bits are affected after executing this instruction. So whenever you perform a mathematical operation or a logical operation, you may find that the result might have a carry. So if the result has a carry, then C bit from the status register will be set as 1. Digit carry is a carry from the lower digit to the higher digit. Okay. Then 0 flag, and you have an overflow flag, and you have a flag for negative numbers. So all these instructions are listed here in the table. Okay. And when you scroll down, you can also find an example and an explanation for each of these instructions. So for example, let's scroll down and take any random instruction. So let's say BCF. What is the function of this BCF instruction? It clears a bit inside a flag, inside a file register, or inside a register. So BCF is the syntax, and F. What is F? F is the location of the register on which you want to perform the operation. So it can be from 0 to 255. So you can use any register location inside the data memory. And next, after comma, you have B, which stands for the bit number. The bit number, the bit which you want to clear. So because this instruction is to clear the bit. So each register bit has 8 bits, and from those 8 bits, which bit do you want to clear? So bit numbers, they range from 0 to 7. So you can clear any of those bits. So for example, you can write the instruction. So you can find an example here. BCF flag register. Now the register locations can also be given a name. So we'll see later on how to assign names for register locations. So flag register is just a location inside the memory, and we are going to clear bit number 7 from this register. So for example, before executing the instruction, if the data is C7, so what is C in binary format? 1100. So bit number 7 is the MSB, which is the most significant bit. If you clear that bit, then you get the result as 0100, which becomes number 4, and the lower digit remains as it is, because we are only changing, or we are only clearing bit number 7. We are not changing anything from the remaining 6 bits of this register. So all this explanation you can find here in the data sheet, and you can also find the electrical characteristics in the data sheet. This is also very important. So you have to make sure when you connect your microcontroller, you have to make sure that the power supply, it remains in the range of VDD, which is 5 volt normally, and plus or minus 0.3 volts. So you can only have plus, you can only have, if the VDD is 5 volt, then any voltage on any pin must be between 4.7 and 5.3. Similarly, voltage on VDD pin with respect to VSS, because VSS is the ground, so this voltage can range between minus 0.3 to plus 7.5. Of course, when it is minus 0.3, the microcontroller is switched off. It will not execute, it will not run. And when you increase the voltage to 4.2 volt, the microcontroller will start executing, and until 5.5 volt. So when you increase the voltage to 4.2 volt, it starts executing until 5.5 volt. So all these specifications, you can find it here. So you can find here VDD. So what is the range of VDD that you can use on these microcontrollers? It is 4.2 to 5.5 volt. So all these details you can find in the data sheet. Okay, to summarize again, what is the data sheet? The data sheet is a technical document which summarizes the performance and other technical information related to the product. And you can find the data sheet usually on the manufacturer website. And on the front page of the data sheet, you will find the model number for which this data sheet is applicable, and you can find some basic features, number of pins, the microcontroller family, the manufacturing technology. So all this information you can find on the front page of the data sheet. Then you can find the summary of all the components and peripherals inside this microcontroller, and you can use the bookmark to easily find the information and to quickly jump between different modules of the microcontroller or of the data sheet. There will be a table given to compare the different microcontrollers for which this data sheet is applicable, and you can also find the pin diagram, and you can find the summary of the pins. This is also available in the data sheet, all the pins and their summary, their functions, summary of their functions, and the general purpose registers, the memory organization, name of the registers, their bit names, their default values, the power on values, and the page number on which you can find the detailed information, the bit values, the bit names, and description of each bits, and the instruction set. So all this information you can find in the data sheet. Now coming back, so this is the memory chart of PIC 18F4580 microcontroller. On the left side, you see this is the program memory, and here you have the data memory map. So the program memory, it starts from 0000 until 1FFFFH. So out of all these memory space, here for this particular microcontroller, only the used space or the on-chip program memory is available from 00 to 7FFF. So this is the program memory, and this is the data memory. Data memory is divided into register banks, and each bank is of 256 register locations. So bank 0 starts from 00 to FF, which is 255. So 0 to 255, you have 256 locations. So GPRs is the general purpose register, and SFRs, they are the special function registers. This table shows you the list of different special function registers available inside this microcontroller. And this is the instruction set that you study in detail in the class. So this table shows you the brief summary of the instruction set, assembly instructions for this microcontroller. Now let us look at the lab on Blackboard. So you'll find on Blackboard under the labs link. If you go there, you can find lab 0 slides. They are uploaded here, the slides which I have explained just now, how to use the data sheet and the lab 0 slides. Both of them, they are explained here. They have uploaded here. And you have lab homework 1. So what is there in the homework? So in the homework, you are simply given the links of the software that we will be using during the lab or during this semester. So MPLAB XIDE. MPLAB XIDE is the main software that we'll be using to write the program of the microcontroller. So when you click on that link, it will open this page, the MPLAB X Integrated Development Environment. And when you scroll down, you will find the download links. So go to the download tab, and if you are using Windows, you can see the link given here, and you can click on this. You can click on this button to download the software. Then you have MPLAB XC8 compiler. MPLAB XC8 compiler is the compiler that we'll be using for writing the program later on in C language. So once again, you'll open this link and you can scroll down and you can find compiler download, and you can download it from here. So for this lab, for this EE366 course, we are only using 8-bit microcontrollers. So you only need MPLAB XC8 compiler. You don't need XC16 or XC32. XC16 and XC32 are for 16-bit and 32-bit PIC microcontrollers. In our lab, we are only using XC8 compiler for 8-bit microcontrollers. Then you have Micro C Pro for PIC. This is optional. You don't have to download it. Then PIC Kit 2 programmer. PIC Kit 2 programmer is the programmer that we'll be using to download the program. So once we write our assembly code, how to copy that assembly code to the microcontroller itself. So we'll be writing our program in the assembly language in MPLAB X IDE. So after compilation, after assembling the code, how do you download the machine code to the microcontroller? So for that we need PIC Kit 2 programmer. So you can also download this software and install it on your own computers. Then you have a few links. Read these chapters on connecting external components to the microcontroller. So the first link given here is the basic connecting tutorial. So this is the link. It explains you how to connect power supply, how to connect reset signal, and how to connect the clock signal to the microcontroller. It's very important. Read this link, read this page, and try to understand as much as possible. Then you have the next link for connecting additional components. So it opens this page and it shows you how to connect switches, push buttons, relay, LEDs, okay, LED displays. So once again, you can go through this page. You can go through this tutorial. Even if you don't understand some of the things explained here, just read it, and later on you'll be able to understand. So when we actually start using these components, you can recall and you can understand it in a better way. There are some more tutorials given here on SparkFun website. So if you go to the SparkFun website, in the tutorials you can find under electrical engineering. There are many different tutorials given here, and you can find some of them might be very useful for you, and you'll be able to revise or recall what you have already studied in your previous labs. For example, how to identify the discrete components, how transistors work, how to use an oscilloscope, the digital logic, AC current and DC current, LEDs, analog and digital, shift registers. So there are many different tutorials given here. If you find anything interesting and if you want to revise anything, you can simply go to these tutorials and you can revise your own. You can revise what you have already studied in the previous labs or previous courses. Then there is another link, the fourth link for elementary details, must know details. So this is related to the logic gears and logic circuits, okay, and the input and output and the memory unit. So once again, go through this tutorial and try to understand as much as possible. And when we start using the different modules, you'll be able to recall them and you'll be able to understand them in a better way. And the next part of the homework is to watch this video from Microchip channel, and it explains in a brief way what is a microcontroller. So this is your homework that you have to complete before we start lab 1. And if you have any questions or any doubts, you can go to the discussion forum. Click on the discussion forum. Okay, we'll open this page. Click on the discussions, and you will find there will be a button here to subscribe. So click on that subscribe button. So whenever there is a new post by anyone, you'll be able to, you'll get a notification by email to know that somebody has written something in the discussion board. So click on the subscribe button, and when you want to ask a question or when you want to ask a doubt, just click on create thread and write your question, and we'll explain you how I can reply there to explain you regarding your question. So every week I'll be uploading the video for that lab. So every week I'll be uploading the video recording of the lab, and you have to watch the video before the live session, and you have to complete any activities given in the video, any activities given in the lab, you have to complete them before the live session. So in the live session of the lab, we will only discuss any doubts or any questions or any problems that you have faced while completing the activities or while completing the homework. So during the live session of the lab, we will not be actually completing the activity. The activity, you should watch the video and you should follow the instructions given in the video and given in the activities to complete them. And if you have any doubts, those questions will be explained or discussed in the live lab session. And each week you'll have a quiz here itself on Blackboard. You'll have an online quiz, and that quiz will be based on the concepts that you have taken in the previous lab, in the previous week. So for lab 0, you don't have a quiz. So from lab 1 onwards, the next week, so when you complete lab 1, the week after that, that means during the week of lab 2, there will be a quiz based on the concepts that you have studied in the previous labs, which is lab 1 and lab 0. Okay. So all those quizzes, they carry mark, and the lab tests, they carry mark. The activities are for your own understanding and for your own learning. So when you complete the activities, you will learn how to use the microcontroller. Activities are not graded. You don't get any grade for completing the activities or for completing the homeworks. These are for your own learning purpose. You have to understand them, you have to solve them to learn how to use the microcontroller, how to use the different features of the microcontroller. And the grading will be only done based on the lab quizzes and the lab tests. Okay, so that's all for introductory lab 0. So inshallah next week we'll continue with lab 1, and we will see how to use the MPLAB IDE. So until then, install all these software on your own laptops and on your own computers, and go through the tutorials to understand all the details. And we'll meet next week inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Subhanallah bihamdihi, subhanakallahumma wa bihamdika, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilayk.